Hello everybody, this is a little introduction to the distance formula and midpoint formula, two really important formulas in coordinate geometry. Let's see how to use them. Let's go. We're going to look at them both in 1 and 2 dimensions. So let's start with the real easy thing, distance formula. So if you look at this line segment here and you compare it to your number line here, you can obviously see that this is 1, 2, 3, 4, 5, 6, 7, 8 units long. But if you're a smart person, you'll say that, hang on, 16 minus 8, the difference between these two numbers is also 8. Just by the way, 8 minus 16 is negative 8, but the absolute value of that is 8. This one here, 1, 2, 3, 4 units long, but of course 86 minus 82 is also 4. And 82 minus 86 is negative 4, absolute value of 4. Okay, so the way we express that in general is that the distance or the length PQ is xq minus xp, or the absolute value of xp minus xq, where q is the one on the right. I don't know why they really make you do this. Mostly if you just remember that it's the one on the right minus the one on the left, it'll always be positive and you'll always have a length. They get you to remember these absolute values because in some times when you've got a weird orientation or in 2 and 3 dimensions, maybe it makes sense to do the easiest numbers first so the absolute value works, but it is what it is. Here's something that's really important, right? PQ with a line on top means line segment PQ. PQ just by itself is the length of that line segment. Please use correct notation. Moving into 2 dimensions, you'll see that instead of absolute value, we've got squared and square rooted, the square root of the square, same as absolute value. So here we've got the difference in the x's squared plus a difference in the y's squared. Take the square root of that, you get the length. Okay, where does this come from? Well, actually it's just the application of Pythagoras theorem. So if you think of this as a triangle, this is A, B, and C. Well, A squared plus B squared equals C squared, so C equals square root of A squared plus B squared. This A is just the difference in the x's, xq minus xp. B is the difference in the y's. That's the formula, that's where it comes from. Let's see how it works. So here we go, we've got some numbers here. So all we have to do is put these numbers in. 2 and negative 2 go here. 4 and 1 go here. So you'll have square root of 4 squared plus 3 squared. Now if you're a smart person, you look over here and you go 1, 2, 3, 4. Whoops. And over here you go 1, 2, 3. That's why it's 4 and 3. And you'll simplify until you can't simplify anymore, and you'll say that the length is 5. Let's do another one. This one, okay. All we do, this is a negative slope, but there's no difference really. All you do is you put the x values in, you put the y values in. So 3 minus negative 2 will give you 5, and negative 3 minus negative 4 will give you negative 7. Just to check that again, look, 1, 2, 3, 4, 5 across, 1, 2, 3, 4, 5, 6, 7 down, so it's 5 and negative 7. Square them, add them together, you get square root of 74. You can't simplify that anymore. We'll just leave it as an exact value, square root of 74. If there's a weird word question where you need a decimal answer, then you'll use your calculator and work out what square root 74 is, but for now, let's just keep it in surd form or radical form, square root 74. And that's it. That's how you use the distance formula. Just FYI, in 3 dimensions it works the same. Okay, if you want to know the proof of this, you can work it out yourself. Just draw in 3 right angle triangles here and you'll see how that works nicely. Let's do midpoint formula. Well, if we got this line segment here, you want to work out what's in the middle. Well, pretty obviously, the middle is halfway between 8 and 16. Now here, that's easy to see, it's 12. If it wasn't so easy to see, what would you do? You'd add them up and divide by 2. You take the arithmetic mean. Same here, halfway between 82 and 86 is 84. Or 82 plus 86 divided by 2 is 84. So that's our midpoint formula. When we're in 1 dimension, we just get our 2 points, or 2 x values, add them up, divide by 2. That tells you where the midpoint is. Now, it doesn't matter if you do q plus p or p plus q, same difference. You get the same answer. I like to do it q plus p because I just tend to like to write things in the same order all the time. All my formulas, slope, distance, midpoint, I put the q first and then the p. Some people like to do p then q because in this formula it's different because it's a plus. The other formulas are a minus, but you do you, okay? Here we go. That's 1 dimension, let's do 2 dimensions. So 2 dimensions, it's just the same thing with the y's as well. Okay, halfway between xy and xy is the half of the x's and half of the y's. You can prove this easily a number of ways. You can use slopes, you can use Pythagoras rule, you can use trigonometry if you really want. You can use similar triangles, that's the easiest way, right? This triangle, you get a triangle that's half the size, so the hypotenuses of this yellow will be half of the hypotenuse of the orange. So this will be the midpoint, because these two are equal. So where is that? Well, that's halfway along the x values and halfway along the y values. That's all it is. Okay, I know that's not a very formal proof, but not really concerned with proofs. Let's see if we can use it. Okay, let's put these numbers in. X values are 2 and negative 2. Y values are 4 and 1. Just sub them in. You get 0 and 2 and 5 and 2. So you can write 0 and 5 and 2, or if you're a decimal person, write 0 and 2.5. And then just draw it in, check it looks right, and check it is right. Okay, here's another one. Same again, put in your x values, put in your y values, simplify. And I would leave it in fractions, half, but if you're a real decimal person, put it 0.5, 0.5, plot it up, make sure it looks good, make sure it's correct, and you're good. Okay, so that's the midpoint formula. And just, again, just for your information, it works in 3 dimensions as well. You can prove that by using slopes, by using similar triangles, by using Pythagoras. You can even do it with complex numbers if you really, really want. But that's a good project for you to explore. But all said and done, there are your 2 formulas. Okay? If you're in 1 dimension, just ignore these y parts, and that becomes an absolute value. But easy formulas to use, but real important formulas too. All right, good luck with that, ladies and gents. Peace.